Welcome back, guys. Today's video is going to be covering ions. Now, ions are simply the charged version of a species on the periodic table. So, if we take a look at lithium versus lithium plus, what is going to be the difference here? Well, we know that the number of protons is never going to change, right? Protons and neutrons are not going to change with ions. When we're talking about ions, the only thing that changes is the number of electrons. Now, when we remove an electron from lithium, as we see over here, that electron's gone, we now have 3 protons and 2 electrons. That leaves us with 1 extra proton, leaving us with a positive charge. And when you have an ion with a positive charge, that is a cation, okay? So that's our first type of ion. Now, if we look at fluorine over here, they both have 9 protons. This fluorine has 1, 2, 3, 4, 5, 6, 7, 8, 9 electrons. So there's going to be no charge on this fluorine because the protons and the electrons cancel out. Now what about over here? Still 9 protons, not going to change that. However, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons, right? So there's going to now be 1 extra electron over here giving us that negative charge. And when you have an ion with a negative charge, that's going to be an anion. So cations, positively charged ions, anions, negatively charged ions. Now, one big concept that we're going to need to know is comparing size. So if you're looking at lithium versus lithium plus, or just any neutral atom, I should say, with the cation version of that atom, what is going to be the difference in the size? So when we have a cation, we're always going to have an extra amount of protons compared to electrons. So what's that going to do to the size of that atom? Well, you can think of the protons as shrinking the atom down, as that excess number of protons is going to overpower those negatively charged electrons, right? And we know that protons and electrons like to attract because those positive and negative charges like to attract, right? So we can think again as these positively charged species start to shrink that atom in as they overpower those electrons, right? So as a rule of thumb, cations are smaller than their respective neutral species because of that extra amount of protons shrinking that atom down. Now, what about anions? So here, we're not going to have that same effect with this extra amount of protons shrinking the atom. We actually have now extra electrons, right? In an anion, we have an extra electron compared to our neutral species. What's that going to do to the size? Well, 2 negative things repel. Just like a positive and a negative attract, 2 negative things repel. So over here, we're actually going to have more negative things repelling each other, actually causing the anion to be bigger than its neutral counterpart. So compared to the neutral species, we have more electron-electron repulsion, right? More negative things in there repelling each other than the neutral species, so anions are bigger, right? So cations are smaller, more protons than electrons, shrinking in the atom. Anions bigger than the neutral species, more electrons, more repulsion, making that atom bigger, right? So if we take a look at this practice problem, circle the bigger species. Compared to magnesium, magnesium 2 plus is going to be smaller than magnesium, right? This is a cation, right? And that means we're going to have 2 extra protons than electrons, right? So that magnesium is going to get shrunk even smaller, right? Those protons are going to overpower those smaller number of electrons and shrink the atom in tighter. Now, what about Cl versus Cl minus? Cl minus is going to be bigger than Cl. We're going to have an extra electron with Cl minus, right? More electron-electron repulsion, right? Negative things repel each other, resulting in a bigger species, right? So make sure you are good with ions and make sure you know that cations are smaller, anions are bigger. Thanks for watching and make sure to check out more videos on the channel.